Hello everyone. Today I'll be presenting findings from the paper titled Experimental Acquisition, Maintenance, and Transmission of Methicillin-Resistant Staphylococcus aureus by the common bedbug Cimex lectularius. This was authored by Herrera, Chaussee, and Pietri. My interest in this paper was sparked by a thought-provoking seminar delivered by Dr. Jose Pietri in March at University of Florida. In this presentation, I will delve into the fascinating world of bedbugs and their potential role in the transmission of MRSA, trying to do it justice as Dr. Pietri did. The common bedbug Cimex lectularius is a widespread urban pest that predominantly feeds on humans, leading to infestations in various built environments, whether it be mud in Madagascar or apartment buildings in New York. Despite their prevalence, the role of bedbugs in transmitting human pathogens remains uncertain, so we don't really know how problematic they are. So MRSA is a leading cause of skin and soft tissue infections and poses significant public health challenges due to its high transmissibility and environmental persistence. While past reports suggest a potential link between bedbugs and MRSA transmission, experimental evidence is lacking. This knowledge gap highlights the need for comprehensive research into the dynamics of MRSA acquisition, maintenance, and transmission by bedbugs, hence the rationale for this study. This study is executed in a controlled laboratory experiment to address some key questions. Can bedbugs acquire MRSA through blood feeding on contaminated membrane mimicking human skin? How does MRSA persist on the surface and within the gut of bedbugs over a period of time? And is there potential for MRSA transmission from bedbugs to an uncontaminated membrane during the subsequent blood meal? This laboratory approach was chosen considering that bedbugs feed on human hosts and are likely to come into contact with MRSA from colonized individuals during blood feeding. So the experiment mimics real life interactions of humans and bedbugs to understand if the bedbugs could be a potential vector of MRSA after all. The scientists used a strain of bugs called the Cincinnati SRL strain. These bugs were kept in plastic jars with cardboard for shelter in a controlled environment and were fed rabbit blood once a week using the feeding system. They grew the MRSA infectious bacteria on nutrient agar in a way that allowed for concentration adjustment to a desired level. And to see if the bedbugs could pick up MRSA from a source, they allowed the bedbugs to feed on blood through a MRSA-contaminated membrane, as shown here, and they checked if the bugs had MRSA on them both inside and out after that. For maintenance, they checked if bugs could keep the MRSA on them for some period of time after feeding, and they did this by measuring the MRSA levels on the bugs at different times after they fed on the contaminated blood. So that happened at 0, 3, and 7 days, and they checked inside and out again. And finally, for transmission, they wanted to see if bedbugs could pass MRSA to another source. So they allowed the bedbugs that had fed on the MRSA to feed on a clean membrane, and then they checked if MRSA had ended up on that membrane. With all the results, they did a statistical analysis using a one-way analysis of variance and a Tukey post hoc test for statistical significance. So bedbugs in this study were exposed to MRSA while feeding through a contaminated membrane in three of the separate trials. Control bedbugs from the laboratory colonies and the materials used for feeding were made free of MRSA. They examined the bedbugs on days 0, 3, and 7 after exposure for the presence of MRSA using dilution plating. After feeding, all of the bedbugs were found to have MRSA on their outer surface, but they observed significantly more MRSA on the bedbug surface at day 0 as compared to day 3 and 7 after exposure. This indicates a decrease in surface contamination over time, as shown in the graph on the left below. In contrast, they found significantly more MRSA inside the bugs at day 3 post-exposure as compared to day 0 and 7, suggesting that MRSA multiplied within the bugs after ingestion, and this is also shown below on the graph on the right. Results from testing the transmission of MRSA from bed bugs to sterile membrane at 7 days post-exposure demonstrated that the transmission of an average amount of MRSA in 2 of the 3 replicates occurred. So therefore, the overall results showed that MRSA can be acquired by bed bugs, it can persist on them, and it can be transferred to sterile surfaces. So this study provides new evidence that bed bugs can acquire MRSA by coming into contact with it on surfaces through feeding. It also offers the first quantitative proof of MRSA replication in bed bugs and demonstrates that bed bugs can transfer MRSA from contaminated to uncontaminated surfaces during subsequent blood meals within a time frame relevant to real life. Previous research in the literature had isolated MRSA from the field collected bugs, but without confirming its localization within the bugs. This study bridged the gap by demonstrating the acquisition, maintenance, and potential transmission of MRSA by bed bugs under conditions mimicking natural exposure. The authors hypothesized that MRSA transmission by bed bugs likely occurs through mechanical means such as contact with contaminated surfaces during feeding. This aligns with the fact that MRSA survives on surfaces for extended periods of time. So while the role of bed bugs in MRSA transmission may be minor compared to other factors, it's important to consider their potential contribution, especially in communities with high rates of both MRSA and bed bug infestation. Based on these results, the next direction for research could involve conducting field studies to validate findings in real-world bed bug infestation settings. Epidemiological investigations could be conducted to assess the association between bed bug infestations and MRSA infections in human populations, and experimental studies could delve into the specific mechanisms of transmission. So overall, these next steps would provide more comprehensive understanding of how bed bugs contribute to MRSA transmission and inform the development of targeted interventions to prevent and or control this risk. Thanks for listening to my presentation. Have a good day, y'all.